Good morning and g'day. My name is Brandon Koloff. I am the lead reviewer on the Neurosymbolic Artificial Intelligence in 2025 systematic literature review, which we are conducting at the University of Maryland under the supervision of Professor Regley. Today I'm going to take you through the entirety of the data extraction phase, starting here with the papers themselves and how we're going to group up and dish out the papers per reviewer. Moving into then the data, the exploration phase for the information required for the data extraction phase. So looking at how you can find the information on that paper and how you can find that and everything that's required there. After that, I'll take you through the full text review and just point out some of the things that you should be noting for the full text review. And prior to doing that, we'll be looking at the Google form that is going to be used for the data extraction itself. After we go through the Google form and the full text review, I'll take you through the requirements of the reproducibility step. As a part of this, we are adding in, as a part of this systematic literature review, that is, we are adding in this reproducibility step to ensure that everything that we are reporting on is 100% across the board. And I'll take you through how we're doing that. And then lastly, we'll do a complete run through of two papers, one that was excluded and then one that was included for the data extraction phase for the systematic literature review. So to kick off with, let's start with the papers themselves. So there is an Excel spreadsheet that lists out all of the included papers. So far we have roughly 550 included papers that we're going to be looking at as a team. Now, the number of papers that are going to be assigned per reviewer is going to be very dependent on how many reviewers we get in the final instance. At the moment, we have 6 reviewers and we're looking to recruit some more through this. So please, if you're seeing this now and you're interested on coming on board with this, send me an email or get in touch with me however you can, and we will talk about including you within this systematic literature review. For the papers themselves, so at the moment we have divvied them up into 6 different clusters, ranging from cluster 0 from logic-driven language within neurosymbolic components, all the way up to logic constraints with learning. The cluster that we'll have a look at today is event-centric neurosymbolic pipelines, and the 2 papers that we're going to have a look at are just the first 2. The first paper itself, we actually excluded as we could not reproduce the results, and we'll go through that in a minute. And then the second paper, we could reproduce the results, so we are going to include that. To find all the information required in the data extraction phase, what you'll have to do is take either the title or the paper ID from this spreadsheet and punch it into Ryan. Now you can do that by looking at just the included or all of the articles if you'd like to, and then just search for the paper itself. As a part of the title and abstract screening phase, which was conducted with Ryan, we required that all papers that were included as a part of the title and abstract screening phase of this systematic literature review needed to have some code repository so we could reproduce. So every single paper that is included should have a link to the GitHub or a link to the Hugging Face or some online code repository for the project itself. On Ryan as well, you should also be able to find information on the authors, where it was published, and then the URL to the publication itself. But if you can't do that, then of course you can just do a Google search to find it. So the neurosymbolic video search, from just doing a Google search, we can find the archive paper. There's also a GitHub. There's also an ACM digital library entry for it. But the place that we're actually going to take the article from is the Springer Link Nature publication where it was published in. So we can see that just here. For this specific piece of literature itself, we also had a GitHub for the architecture, a GitHub for the data set, and a GitHub for the Hugging Face for the data set as well. So once you have all of the artifacts that are required for this full text review of the data extraction phase, which again should just be the full text itself, where that full text was published, which for this example was Springer Nature Link, as well as the link to the code repository for the framework, and if required, a link to the dataset if it wasn't already publicly available prior to this paper coming out. Once you have those artifacts, you'll move on to the full text review, which is essentially just reading the text in full so that you can extract information on it. Now, prior to taking you through the things that you should be noting down on this, I'd like to take you through the data extraction table itself, just so that we can prime ourselves for the types of information we should be looking at and the things that we should be noting down. I do also recommend that you go through the data extraction table at least once in your own time prior to doing any of this, just so that you can kind of, reiterate the things that you want to be noting down for this, but that's totally up to you. Now, right at the start of this, we have information on just the documentation for the systematic literature review itself. So all of this information has already been provided to you, and this is within the documentation, but it's just up here as a reminder of the important things like, what we're actually doing with this, so what the review question itself is, and what the inclusion and the exclusion criteria is. You don't have to read any of this at the start because you already should know all of this. It's within all of the documentation, but it's an easy way just to be able to reference it right up here. So for this systematic literature review, we are, of course, as you can see, using a Google form for the data extraction table, and it's a sectioned off Google form. Section 1 here includes this preamble here, as well as the administrative stuff that we need to record, who is doing the data extraction for this piece of literature, as well as what the actual piece of literature is. So, what the DOI is, what the paper title is, where it was published to, all that good stuff. Section 2 talks to the confirmation of the eligibility for actually screening this paper and for including it within the systematic literature review itself. So if you read through the paper in its entirety and for any reason you answer no to any of these questions, then you'll be excluding this paper. Now, this was already done within the title and abstract screening, so all of the papers that you're looking at should be fine to pass the eligibility screening, so they should all be getting past all of these. They might not get past the reproducibility step, which we talked to down here, but they all should pass through the rest of them. But that was just looking at the title and the abstract. So if you read through the entirety of the paper and for any reason you think, oh, well, actually, this paper isn't an original research study, or this paper did not have a quantitative evaluation, then you'll mark that as no, and then you'll skip this paper in its entirety. You'll go down to section 9 and you'll just say why you skipped it. If for any reason you could not reproduce this paper, which are these two questions down here, you'll still continue on and you'll fill out section 3, but you'll then skip through to section 8, so you won't fill out sections 4 through to 7, as we'll be excluding that as well. So if for any reason you can't produce or reproduce the results that are reported on within the paper, you'll also be excluding and you won't fill out most of the form. But, given all of these checks are fine and the paper is something that we should be included within this, and the paper is reproducible and you did reproduce the results, you'll then move on to this. So section 3 just talks to the reproducibility. So here you'll just note down, where the code is kind of, where it comes from, things about the documentation. So, whether or not they described how to implement it, and things like the data set, if a new data set was released for this, whether or not it was and where you can find that, as well as some basic reproducibility checks, which are pretty standard across most of the publication kind of venues. So all of them should be included within any of the published papers that we're looking at here. So once you finish section 3 and you've kind of reported on all the reproducibility stuff, we'll then go through and look at some more detailed stuff from the paper itself. So section 4 down to section 8, this is where you're going to have to really take the information from the paper itself, extract it, and then report on it in these sections. Section 4 itself is just some general stuff. So it's looking at, what you think the primary neurosymbolic AI domain that the paper talks to is, as well as whether or not they claim any real-world applications, and then giving a very brief description of that application if they do. Section 5 talks to the neural component. Now, section 5 and 6 are primarily just click and play kind of multiple choice or checkboxes where you can come in and you can say, okay, well, this paper talked about, for example, llama in a instruct format, and that's what they used. So you just click through and you say what the paper used for the neural component and all of the information on that. Section 6 is then talking to the symbolic component and noting down some information on that. Again, section 6 is just click and play, so you can control F to find the specific symbolic project that was used if one was used and it's not novel. And then just reporting on some of the stuff like the reasoning or inference engine that was used within the study itself. Most of that, again, is just click and play with these checkboxes. Then going down to section 7 here, section 7 is then your kind of synthesis and your quality appraisal of the paper itself. So this is where you kind of have to synthesize, or you have to come up with how you kind of feel the paper, push the boundaries of the kind of literature within neurosymbolic AI. You'll note down things like the key findings, whether or not the authors reported any limitations. And then you'll also say whether or not you think it's relevant to our research objectives, and then things like the perceived novelty of how novel the research that was conducted was, and the clarity on how they reported it. Section 8 then talks to the metrics and the evaluation that was used within the paper, and this is so that we can kind of report on the metrics that were used within the broad literature here. Again, most of this is just click and play, so you can just click through, Control F, find the stuff that the paper here reported on for the metrics of evaluation, click it, and then move on. So that should be pretty quick. And then section 9 is the final decision. So again, this is a section that you'll skip to if for any reason you want to exclude the paper, and you'll note that down here. But if you don't want to exclude the paper and we're including it, you'll note that down. If you do exclude it, then you'll say why it's excluded, and these are these right here are the eligibility screening points that were up the top. So again, most of these should be already checked off and they should be fine. The only one that we should really be kind of excluding for is this 8th one down here, which is the reproducibility, which is the step that we're conducting here in conjunction with this data extraction phase. But for if any reason you read through the paper and you think, well, actually it doesn't have a good grounding to be a research article, then you can also exclude it on that basis. So that was the data extraction form in its entirety. Now let's have a look at actually doing a full text review. So let's just have a look at the things that I thought were important to note down or highlight during my full text review. Of course, you have to do a full read through each of the pieces of literature that you report on. But I'll just take you through the things that I then noted down that I thought were important to then extract out to report on. So right up here in the abstract, the first thing that I kind of want to look for is any claims that are being made, and then also any kind of descriptions as to what they're proposing or what they're doing. So here in yellow, we can see that they're proposing a new system, and then here in blue, we can see that this new system that they propose then improves the F1 score for identification of complex events by 9 to 15%. And they benchmark that against things like GPT-4 for reasoning. Now, the next thing that I thought was important to note down was the methodology. A lot of the information that you extract out for sections 4 down through to section 8, which is kind of talking to the method or the way that the systems or the proposed neurosymbolic systems work in here, is described very much within the methodology of a lot of these papers. So this should be something that you should be noting down to then report on within the data extraction table. Another thing that you should be looking at is any links that are in the paper itself. You should be screening for them early so that you can then use those links to be able to reproduce the results. And of course, any data sets that are required to reproduce those results and the actual experiments conducted for the results themselves. So the results are very important, as you're going to have to reproduce them to include them in this study, but then also looking at the experiments, how they are setting these up and how they are kind of showing their metrics for evaluation and what metrics they're actually reporting on. So that's what I noted down when I did a full text review and I read through the entirety of the paper. Now let's look at the reproducibility. So you've read through the paper in its entirety. You've then collected out all of the repos that you need to be able to reproduce the paper. The next step is, of course, to do the code-based reproducibility and reproduce the results that were reported on within the paper. So For this specific paper, Neurosymbolic Video Search Temporal Logic, they actually shipped out a GitHub with a Docker file. Unfortunately, they did not build the Docker file themselves and upload it to Docker, so I did have to build this myself. But because they provided a Docker file, it should be easy to reproduce, as this is a containerized environment. They ship out everything that you need in it, with all of the environmental variables, all of the base images, everything is there. So we should just be able to take this GitHub repo, build the Docker file, run the experiment, bing bang boom, Robert's your brother's mother, results are there, should be easy. Unfortunately, nothing ever works out that way, and when I pulled the GitHub and then tried to reproduce the Docker file, which is this one just here, I ran into these errors. So this error shows that the Docker file, just as a base, will not work. I tried to run this on my Mac, but it should be fine to run anywhere. Any Unix system or Windows system Docker file should be able to run and build. Unfortunately, there is a fatal flaw within this Docker file, so you can't actually build it, and that fatal flaw right here, which we can see in the log, is that you cannot build this with the dependency Carl Storm. Carl Storm, I did a bit of digging, and that is required to do the actual evaluation on the project in its entirety, so without that, we can't actually run any of the evaluations on this. So this is a huge issue, right? Carl Storm ships out with a CMake file requirement of 3.22, and the base image here that is used, Ubuntu 20.04 with CUDA, only has a CMake of 3.16, I believe. 3.16. And we need something of 3.22 or higher, so we can't actually run this Docker file, which is quite concerning. But, we shouldn't just give up because the Docker file doesn't work. So after doing that, I then came through and downloaded collected the GitHub onto Zaratan itself. Now, as a side note here, everyone who is currently on the review team should know, but anyone who is looking to come on to be able to do this reproducibility step, if you come on board, everyone is given an allocation under the Zaratan allocation for the systematic literature review, and you can use the compute power on Zaratan to run anything that requires something bigger than a personal computer to run it. So within the Zaratan environment, we have this shared folder that we're going to be using for any of the data sets, just in case we need to use them a couple times. So down here we have this right here, regularly shared under here. This is actually a symbolic link that I made. So if I copy this path and then find it, I can see that under this right here, which is our project regularly project under shared data sets, that is where the all of the data lives, and we can see them here. So this is where all the data sets that we're going to be using for this reproduction will live, down in this shared folder. But you also will have space on your allocation to be able to download anything that is substantial and be able to run it. So back to the reproducibility step for Neurosymbolic Video Search. You can see here that within the dataset folder, I've actually downloaded the Temporal Logic video dataset, which was the dataset that they reported on. And then I've also down here within the Neurosymbolic Video Search Temporal Logic, I have downloaded that GitHub repo as well. And I then tried to reproduce it just by building the environment from scratch with a virtual environment. And I ran into a lot of errors as well. And they were, again, errors that were prominent just up here and errors that were prominent here due to the CMake not being good enough. So the issue that we are again seeing here is that we cannot make the environment with the Carl Storm requirement, which is required to be able to run the quantitative analysis on this whole project itself. So we can't actually, and again, I didn't just try once here. I attempted multiple times through multiple different ways of trying to do this, but every single time I tried to build this with this dependency for Carl Storm, I was blocked and it failed. So I tried multiple times. I tried with the Docker file did not run. I tried with a virtual environment, the virtual environment did not run, and it just did not ship out with something that could actually be built, and I could not run the experiment. So this is a desk reject. Because I have gone to the extent of trying to run the experiment by building the Docker file and the Docker file failed, And then also I have tried to create the environment required to run this project, and it is not doable because of the requirements for the evaluation in here, and they cannot actually run. I can't reproduce the results. I don't know how they did it within this paper. You know, they reported within this paper on these results and they showed this. We can actually run this pipeline to get some of these images, but we can't actually run it to get any of the results in this table. It's not doable at the moment with the environment that they've set up. And we can show that here within the Docker file, and we can show that here within all of the failed build attempts. So because of this, this specific paper right here is going to be a reject. So let's now go through here and then look at how we are going to note that down. We've read through the paper in its entirety, and we have attempted to reproduce the results that are reported in the paper, and we were not able to. So let's have a look now at what the reporting requirements for an exclude paper are. Up the top here, it is no different to what we have for the include paper, in that we still have to note down all of the preliminary information for where the paper was retrieved from. So the DOI, the title, the publication year, the journal or conference that it was reported in, all of this stuff still needs to be noted down for this specific paper here. So this was a introduction of a new framework where they are proposing a system here. So this is a framework or demo paper which introduces this system itself. And a brief summary of this paper, essentially it was a proposition for a pipeline that pairs a vision language model for frame semantics with temporal logic to be able to look at long horizon events in a video. And it was paired with a storm model checker to be able to localize complex long horizon events to do that. It also claimed to boost the F1 score from 9 to 15% over the baselines tested, which were GPT-4 reasoning. Section 2, so again, this is just looking at the eligibility. The eligibility for this paper was fine on everything except for the reproducibility. So this paper was still written in English. It was not a review, so it wasn't something like a systematic literature review or a survey. This paper was, it did present an original research study. So, you know, they presented a system, and then they conducted testing on that. So that is grounds for an original research study. This paper was reported on in Springer Nature. So this was peer reviewed. If it was only on arXiv, that's fine, but you just have to note that down here. This paper also did have an associated code base. It actually had the two. So it had this one here for the framework and this one here for the data set. It did show quantitative evaluation. So down here within the results section, they did show the quantitative evaluation of the system against some baselines. And the full text was readily available, both on arXiv and also via Springer Nature. Unfortunately, we were not able to reproduce the results, so the study was not reproducible. If, for example, this was able to be built, then it would be reproducible, but we could not reproduce the results. But because we could not even build this study is not reproducible at all, and the results were not reproduced. So because we have answered yes to everything above except these last two questions, we are still going to continue on as it is not excluded on the grounds for anything but reproducibility. And within the reproducibility, we still want to report on Section 3 and Section 8. So we will continue here on for this, given that it is just these two last questions on the reproducibility that were noted down as a no. So Section 3 is just going through the administrative information for how you reproduce this. So you should have all this information from when you were trying to run the reproducibility here and here. So the URL is just the GitHub URL that was used to be able to download the repository. The framework or the language that was used here, we can kind of note this down from this one right here. It's primarily Python, but they also do use a lot of external libraries with PyTorch and C++ to build some of those external bindings. The commit tag, you can find the commit tag for most of these by looking just here within the releases. For this one, it was version 1 on GitHub, so that's the version here, and we can provide a link to this GitHub release tag just there. For the documentation, now this specific repository itself didn't offer much documentation. There was the README file just here, which did talk to how to install and then also running the system, and it did actually have some reporting on the issues. There were some people that did report on some issues, but none of these issues reported on being able to build it from the base with that Carl Storm. So I assume here that no one has tried to reproduce the results from a quantitative aspect, and there is no issues with that, or issues reported with that. So there was partial documentation. They did provide some level of documentation on how to run within the README file, but it wasn't very extensive, and there weren't really very many comments within the code base itself. So this is going to be a partial. We were not able to build it all, so this is obviously going to be a no. This right here, there was a new dataset release, so this is going to be a yes. This new dataset was this one right here and here. So this is a yes, and we can provide the link to the GitHub or to the Hugging Face. Either would be fine. With the reproducibility checks, limitations were reported on in this paper, so we can see down here after the results section the limitations, which were briefly but still reported on within the paper, but they did not report on an ethics or a broader impact statement, so that's a no. They did kind of report on some of the hyperparameters that are required here, so they reported on things down within their appendix on the hyperparameters, but by and large they didn't really give us very much information on the parameters needed for the neural component, so this is just going to be a partial. The pre-processing, so there was a lot of pre-processing that was required to run this, and fortunately they did provide those scripts, so this is going to be a yes. So this one here, the methods for setting random seeds, this is something that you want to look for in any neural network or any neural component that requires some sort of randomness. So for example, if you're using an LLM, let's just say Llama for example, and you are required to do any sort of forward inference on that, then there are some parameters that are very much tied to the randomness of the forward inference. So things like the temperature and the burstiness, things like that. And other things, if you're doing some sort of a convolutional neural network, then there is going to be some inherent randomness in that. So we want to know about the seeds required to be able to do that. And if there is a paper that talks to some sort of a randomness within that, we want to know about that. This paper itself didn't really use anything that required that randomness within the neural component or within the whole pipeline, so this is going to be a not applicable. The exact run command very much was provided. We had the Conda environment, we had the Docker, as well as the requirements.txt for the virtual environment, so this is a yes. They didn't talk at all to the compute hardware throughout any of the paper. They didn't really talk to how they ran on any of the compute for this, so this is going to be not reported. And again, they didn't say anything about the compute, so they didn't list anything about the budget or anything on the number of independent runs that were required to actually make this table right here. Also, there is no kind of variance reported either in this table or down in this these two figures here, so this is going to be a no, as they didn't provide any information on the variance or the error bars. They didn't run any statistical tests, so this is going to be a no. They did provide information on the data set, so up here within the dataset section itself, they talk to why they were required to use the dataset, and then they also did talk to the train validation test split required for this dataset, which was reported on not only within the paper but also within the GitHub itself. So this is going to be a yes. They did also introduce the information for the theoretics of how this works up in the methodology. So up here in the methodology, they gave quite an extensive run through of how their NSVSTL system works. They gave these steps here, which kind of talks to the individual chunks of the pipeline, and they went through quite systematically and thoroughly and described the pipeline itself. So this is a yes. For the data and code license, that can be found just by looking at the GitHub. So here within the GitHub of the framework itself, we can see that the license type is MIT. And then if we go to the Hugging Face here, in here, the license type is also MIT, not CNC. Just noted up here. Right here, license type MIT. So both the code and the data are MIT for this. The notes on reproduction, so I will say this again, we could not build this because of the issues with Storm, and that being a dependency of the evaluations for the quantitative analysis of the system. So because we could not build the environment through Docker, and we could not build it virtually with a virtual environment on Zaratan, we could not reproduce these results, and we're noting that here. We cannot do the verification stage, so we cannot verify the quantitative scores here, and we cannot reproduce the results reported from this paper. Here, no, the results were not reproduced, so we are going to select no here, and because the results were not reproduced, we are not going to go any further. We're on section 3. We're not going to go through and answer sections 4, 5, 6, or 7. We're going to go straight to section 8 because we could not reproduce these results, so this is going to be excluded from the systematic literature review. The metrics and evaluation. So this is something that we still want to report on even if we couldn't build, just because we want to know what the metrics for evaluation was on, just in case we do get in contact with the authors and we are able to get them to fix the system. So the primary task that was reported on with the metrics of evaluation can be found within the results section right here, evaluation and metrics, and they note down here that they use precision, recall, and F1. So here we have F1, precision and recall, and accuracy were the 3 primary metrics that were reported on within this task. Within the split and train protocol, it was the official one that was released, so this is going to be just the official split train protocol. Within the evaluation assets provided, they provided both the scripts as well as the data and the Docker files. So those were the 3 that they provided for that. Within the dataset used for evaluation, they actually use their own custom dataset. So we come down here and we note that it is a custom dataset. And for that, they use their own temporal logic video dataset. And we can link that just here, which is the link to this Hugging Face. They do also provide the motivation for the dataset. So if we go up to the paper again and we look at the dataset section, they provide a quite extensive breakdown of the dataset, the compilation, and they also provide a pretty good rationale behind why they wanted to use their own dataset. And then here, whilst they did use some remnants of Cocoa, with Microsoft Cocoa within the dataset here, it wasn't the primary dataset. The primary dataset was, of course, their custom one, so we're going to say not applicable because the dataset used was not one that was external to this project. It was a custom one. For the baselines and the ablation studies that they compared against, they say within their paper that they compare against GPT-4 as well as 3.5 and 3.5 Turbo Instruct. They didn't do any human evaluations, so this we're just going to leave blank as we're only answering this for if it is applicable. And then the reproduction outcome, it was not reproduced at all. Again, here we're noting that it is not reproduced because of a build failure, and then we don't really have to say anything on the notes for the metric computation quirks because we couldn't get to that stage anyway. And then for the final section, the final decision, we are excluding this. We are excluding it because the reported results were not reproduced. And then the action items that we need for this is to follow up with the authors regarding the build failures with Storm. From that, we can just submit and we are done. We have just submitted one paper for the data extraction phase. Next, we're going to go through an included paper, so we'll see what that looks like now. So we've been through and we've had a look at what an excluded paper looks like within the reporting requirements of the data extraction phase. Let's go through now and look at a included paper and what reporting requirements we have for that. So the second paper from this cluster is a hybrid neurosymbolic approach for complex event processing. We can go back to Ryan and we can search for that by name to find this entry or this entry just here. We had a duplicate with this one, both of which were included. Because this is a duplicate, we'll only look at one of them, and we will search this name here to find the archive paper back from 2020 when they first reported on this, and they do actually have some results that they reported on, but then also the expert systems with applications venue publication from Science Direct, which has a much more extensive reporting mechanism. Both of these papers actually reported on the same system, which was DeepProbSep, which they have linked in these papers to this GitHub repository just here. So we can take this paper and then start looking at it. Both papers actually here and here. I'll take you through just the notes that I had for the second paper because, again, both of these were reporting on the same system. This first paper did have some reporting just here, but it wasn't very robust. They didn't really do much. This second paper, however, they had 7 different experiments that they reported on. So from this first paper, they state that they present a system, DeepProbSep, which is a complex event processing approach designed for 4 objectives, these objectives just here. They don't state outright what they kind of claim the system can do here. They do in the first paper. They do claim just here that they are able to train with much fewer labeled data points than pure neural networks, and then learn and classify individual events, and then they test that on the Sound 8K data set. In this paper here, which is their second paper, code link just here, they here state that they propose this architecture, DeepProbSep, where a reasoning layer is used by differential logical programming that enables explainable and robust adversarial conditions. They state that they use ProbLog and DeepProbLog for the symbolic components, and then down here they go through pretty extensively the subsymbolic or the neural component, which was a convolutional neural network linked with a multi-layer perceptron. This was a novel convolutional neural network which they used, and they used this with digit NN. So they essentially took digit NN and kind of reformulated it a little bit to work with the system in a novel way with that multi-layer perceptron. So once they did that, they then classified on the MNIST data set, and down here within their results section, they report on these here. Now, reading through the paper, there was quite a lot. Here they go through the experimental design. They note seven different experiments that they conducted, all of which now have to be then gone through. They conducted these experiments with a range of different ablations or a range of different baseline models, which they note here. So they used an LSTM, they used C3D, they also used Neuralplex, and then they used their approach, and they compared all 4 of those different approaches, summarized it in these metrics down here, and then reported on all of that. Now, this was quite a lot to then go through and reproduce. There also was, right down here at the end, another table that they did as kind of a summary table with the Sound 8K data set that they reported on in their first paper, but they ran quite a few experiments in an extensive manner. So they didn't ship out any sort of a Conda environment for this. They only gave the GitHub repo, so we cannot try and build from the Conda environment. But what we can do is then download the GitHub to Zaratan and then create a virtual environment. So I downloaded this GitHub to Zaratan, and then I also downloaded the two different data sets that were required for the metrics of evaluation, which was the Urban Sound 8K and the MNIST data set right here, again in our regularly shared folder just here. Again, the actual path to that is just here. And then what we can do is I set up a wrapper to be able to one look at all of the experimental results. So this is just taken from the experiment. This is this part here. And then what we did was we then ran experiments 1 all the way through to experiment 7, which is just here. So we set up a wrapper to be able to use the GitHub provided code, a wrapper here that used this GitHub provided code to be able to run these experiments on the data set that is provided, and then generate the outputs. Now, we also did within this wrapper use a self-generation task to be able to then run these experiments and then compare the experiments right here in the report, compare these experiments, experimental results that we got to the information that was reported on within the study, and then we ran this in Zaratan. So to run something in Zaratan, you have to make a bash script. I ran this this experimental reproduction with this bash script, and then I also did write this wrapper file to be able to run again this GitHub repository on the 8K data set in the way that it was reported on within the first paper just here, to be able to generate the results seen here. So I was quite extensive here in that I wanted to reproduce all of the resulted experiments from the experiments 1 to 7 on this second paper, but we also did reproduce the experiments from this first paper just here. So with those scripts set up and the bash scripts set up to be able to run the experimental results to get those experiments 1 through to 8, we can then run that on Zaratan, which we did, and we got the experimental results here for this GitHub repo for the deep prob SEP on experiments 1, 2, 3, 4, 5, 6, and 7, and then also on the original papers experiment, which we're just going to call experiment 8 here. We can see here that all of the files were generated correctly and the whole script ran perfectly after some kind of back and forth and after some tests and adjustments. And then we can see the final evaluation results here, which if we go into our summary right here, we can see that they all pass. So the claim which we had to manually annotate here, the key result which was claimed for experiment 1, for example, was that deep prob SEP hits greater or equal to 96% accuracy with 5K samples and outperforms every other window size. And we found this was true. We then also did this for all other 7 experiments, and across the board we found that we had reproduction success. So after running these scripts within Zaratan, all the claims were validated as true, and the same numbers that were reported in the paper just here, paper 1 and paper 2, we found we were able to reproduce and we were able to get the same results. So given that we were able to reproduce this, we'll now go through the data extraction table for this and see what that looks like. Okay, so let's go through now the data extraction using the Google Form data extraction table for the included paper deep prob SEP. If you don't watch anything else throughout this video, this is the one part that I would very much want you to watch because we go through everything in the entirety, and it is a very good breakdown of what you'll have to do for the full text review. I'll timestamp all of the transitions within the video in the description down below so that you can see where you can go to, and I'll make important note for this end section right here. Nothing has changed within section 1 for this data extraction process, as we're just still collecting the same information. So you put your reviewer name, you put down the DOI, title, publication year, what journal or conference it was reported in. For this one specifically, it was Expert Systems with Applications from Science Direct, and a brief summary. This paper specifically introduced deep prob SEP, which was a differential problog and CNN hybrid that then trained end-to-end to be able to form labels for what they called CEP, which was complex event processing. Again, just going through the confirmation of eligibility screening, everything here is a yes. So we'll just skip to the end, and we can see that it was reproducible and the results were reproduced. So both of these are yes. We click continue because we have not answered no to any of these above. Section 3, we're just going through the code and where to get all the information for that. So the URL for the code base, again, that is just this one right here. The language in this, it was primarily Python with a bit of PyTorch, and then they also used deep problog and problog to be able to do the symbolic part. The commit tag, they didn't have a version, so we're just going on when the second paper was released, which was 2023. The documentation, so they didn't really provide documentation in this one either. They provided the README right here, and they provided some information on that, but really it was very partial. There wasn't very much documentation. We were not able to build this on the first time with the virtual environment created or provided, but we were able to build it and we were able to run it, but this is still a no. For the dataset itself, they did not release a new dataset, so we don't have to provide a link. The reproducibility checks just down here, they did provide a limited section down the bottom. They didn't talk to the broader impacts. They did provide quite good documentation down in the appendix of the second paper for the hyperparameters required. And then they did also provide the pre-processing scripts that we used on Zaritan to be able to pre-process the data. With the methods, so within the paper itself, down in the methods section, here they did describe quite well theoretically how to set any of the they did partially kind of talk to any of the randomness required within this within the multi-layer perceptron, and then they also did not provide any of the I'm going to say partial here actually, because they did provide the requirements.txt for the Conda environment, but they did not provide the Docker, so this one's going to be a partial. They didn't talk at all about the compute hardware, so we're going to answer not reported and no to those two. They didn't talk at all about the number of independent runs required to get the results that are looked at down here in this second paper, so none of that was talked to, so this is a no. They did talk about the variance within these results here. They do show the variance in the error bars, so that's good, and that's a yes. They didn't run any of the significance tests, so this is a no. After reading through the paper, it was quite evident that they didn't run any of these. The rationale for the dataset used, they did clearly describe that, and they did also describe the train test validation split. Here within the conceptual outline of the pseudocode, up in the methods section here where they describe how the system itself works, they did describe quite well how here deep probsep works. They went through quite extensively the theoretical framework, and they also went through some of the pseudocode in the appendix down here a bit later. For the code type provided, we can see from the GitHub just over here that the license type is MIT. And we ran 8 experiments spanning 2 papers. Yes, we were able to reproduce the results, so we are going to head on to section 4. So section 4 is different to the exclude section, as we will be filling out section 4 for the inclusion, and we'll be filling out sections 4 to 7, which we didn't do for the exclude. So I'll go through this in a bit more detail than the kind of machine gun bullet feeding I just did for the sections 1 to 3. The primary neurosymbolic artificial intelligence domain. So everything in this section here is kind of up to the discretion of the reviewer or the annotator who's putting this down. So this is how you want to describe here the primary area that was used for the neurosymbolic artificial intelligence pipeline that was generated. For me, after reading through the paper and after kind of getting a gist for what they were doing, I guess you could kind of just infer it from the abstract if you really wanted to, but what they were doing was complex event processing, and they were using differentiable logic to be able to do that. The application areas, they did actually talk to the application areas down in the discussion, so a bit further past the results down here in the discussion, they start talking to the applications, and within the application sensors, they specifically give a demonstration, or they give an example of a demonstration for being able to do Internet of Things sensors for urban siren detection. which they talk to quite extensively. So for the application area, this is kind of the application that you can see the pipeline or the framework that the paper has described working in. For this specific example here, the application area that was described was sensor stream monitoring and adversarial robust detection. And that's, generally a very broad area, but that was the broad area that was discussed not only within this section down here, but also within the description that they gave for the demonstration. The task type pretty obviously was complex event detection, and this should be stated pretty explicitly in the paper what kind of things they're doing. So if they're doing something with image detection, then it's going to be obviously image detection. If they're doing something with question answering, then it's going to be QA. For this, because they specifically said it was complex event detection and then also sequence classification for being able to do stuff like identify some sort of a siren, this was the task type that we're going to tag in here: complex event detection and sequence classification. For the neural component, so most of section 5, 6, and 7, or 5, 6, and 8, sorry, are just click through, where you'll just click on the area or provide something different if it was. For the neural component of this, for example, if it was something like llama, then you could easily just click llama. But for this paper here, they describe up in their methods section just here what they used, which was a convolutional neural network with a multi-layer perceptron, which was not, it was a novel use of a CNN MLP kind of structure. So it's other, and it is the digit NN convolutional neural network with VGG, which was the audio multi-layer perceptron. And that isn't already up in here, so we're going to do an other for that. With the neural architecture, there's a lot here to be able to choose from, but the two that we're going to select for this specific example were CNN and simple MLP. The parameter count, they didn't really report on this. It was about 50 million, but it wasn't very explicitly stated within the paper, so we're going to say not reported. And the release date, we're putting the release date for the first paper, this one just here, which we saw on archive, because that's when the actual GitHub itself, this GitHub, was first released. For the prompting strategy, so this is really only going to be applicable to something that uses some sort of a large language model or some sort of an LSTM. They didn't require any sort of a prompting strategy, so this is not applicable, so we're not going to fill that out. Alignment and then safety filters, there were no safety filters applied. I'm actually going to click off that one because I don't think safety filters are required for this specific setup, specifically just because it's on classification, and I don't particularly think any of that is required for this. This would be something much more suited to, again, a sort of a large language model. The alignment and safety, we've done that. So for the pre-training sources, there are quite a few here to choose from. If you're using any sort of a large language model, then you're likely going to pick a few of these up the top because most of them use that. For this one specifically, they used the ImageNet Microsoft Cocoa dataset to be able to do it. So we're going to click on the image, and then they also used MNIST digits for some of their fine tuning. For the fine tuning, we saw within the paper that when they were doing some of the model architecture fine tuning, it was supervised fine tuning on those task specific labels from the MNIST dataset. So that's our selection for fine tuning. The access level, they had everything open weight, so that was great. So we're going to click on open weight, and then how the neural outputs are used by the symbolic part. So again, this is something that you're going to have to kind of draw out from the paper yourself. This is probably not going to be explicitly talked to in the paper. After reading through the paper in its entirety and looking at the architecture itself, from here, what I could see is that they were taking the probability and then logics and then converting them over into facts to be able to constrain information. So they were going from the sub-symbolic, the probabilities just here, and then they were converting them into the symbolic components. So we're going to say for this one, they were taking the probabilities and then they were converting them into logic, facts and logic. For the existing symbolic project used, they specifically use Problog. Again, this is just click through, so you just find the one that they used. If they haven't provided the one that they've used, you can do this with pretty much any of the click through that you press other and you name it down here. And then here is just the link to Problog. With the symbolic representations, again, just to click through, they were using probabilistic logic. With this, it should be pretty easy. You should be able to just come in, Control F, probabilistic stuff, and then you should just be able to click that off, say, yep, they use Problog, they use probabilistic logic, they did not use a probabilistic graphical model. And then coming down here to the reasoning and the inference engine, again, they're using probabilistic logic engines to be able to do that. And then with the source of the symbolic knowledge that they used, they were using handcrafted authors and domain experts to be able to provide the information. So this here can be drawn out from the paper as well as everything else here. And to be able to mark these down, you can just Control F, find the specific one that you want to put in. And then if they don't have what was specifically used within the paper, you can select other for any of these multiple truths or checkboxes and then actually state what they used. For the integration strategy, this is again quite similar for the integration strategy that we saw previously from neural network to symbolic, but this is just symbolic to neural network. And for the integration strategy, this kind of diagram sums it up pretty well. What they were doing is they were taking the differentiable logic, the symbolic logic that they have right here, and then they were putting it back into differentiable constraints here within the network to train. Again, they use Problog, so just Control F, you can find that pretty easy. So section 8 really talks to the synthesis or your quality appraisal. This is something that you kind of really have to draw out yourself. So you'll have to read through the paper in its entirety. You'll have to look at it start all the way down through to the finish, and then you'll have to make an assessment and judge this yourself. So the first question here are, what are the key findings of the study? And this is going to be very different for each study, and this is going to be very dependent on what you draw out from the paper. For me, when I was reading through the paper for this specific paper, I found that the four key findings were these four here, and this was just from what I kind of assessed from the paper. So this was my self-assessment on what the paper kind of had. The author-reported limitations, if there are any, report them here. This should be pretty obvious to find within there. There were some author-reported limitations within this study here, so I'm just going to note that down here. And then this right here, the reviewer identified limitations. Again, this is your assessment of what some limitations to this was, to this specific architecture were. So my identified limitations that I had for this architecture were that the parameter count and the compute budget were not reported. So the kind of real world deployment kind of is not very reproducible because it's hard to say how we can extend this and how we can project this into a scalable mechanism, because they're not reporting on the compute required for this and they're not reporting on the budget. Though we did kind of reproduce this, so we can report on the requirements for the budget itself if we wanted to later on. This right here is just saying if there were any ethics or legal concerns for this paper. There were no. And then these three kind of sliders right here, again, this is your assessment of how relevant you think the paper is to our research objectives. If you have forgotten those research objectives, again, they are at the start of this whole this whole data extraction table, so you can go back and read them. The perceived novelty, how novel you think this is, and then how clear the reporting is. So how clear you think the reporting is for this paper that we are reporting on. The reproducibility with confidence. Now, again, this is your assessment of how reproducible you think it is. I said for this one right here that it was mostly reproducible because we were able to reproduce all the results, but they just didn't give us these things up here, which were the parameter count, the compute budget, and some of the real-world implementation strategies that you would require. So whilst they were quite extensive, they were just that little bit off the mark. A fully reproducible gold standard would be, they provide everything. They provide great documentation. This one specifically was a bit lacking with the documentation, so it's losing a couple points there. So again, the gold standard would also be something that provides a lot of the information for the hyperparameters and all the things that you need there, and is just kind of, absolute gold standard. Everything you need is there. This one was a little bit below that mark, so whilst we were able to reproduce everything, I'm going to mark it as mostly reproducible with some minor gaps. And then this here is just how confident you think you are on all of the assessments you've just made previously. Section 8 is the metrics for the evaluation. So you'll have to take this from the results section down here where they talk to the, I can't control F in OneNote, but down here within the results section, they talk to the different things that they are looking at. After reading through the paper, I can see that the things that they are reporting on for this were the accuracy, the precision recall, and the F1. They didn't really provide very much of that in the raw logs. They did provide the results table, which was good for the 7 experiments, but they didn't provide that within the raw log, so I put a partial for that. The split protocol, they did report on this within their paper. Again, this is just something you have to draw out from the paper itself. And then the evaluation assets provided for this GitHub right here, they provided both the evaluation scripts, and they provided where you can get the checkpoints to the neural models that we use. So we're going to put both of those. They also did provide the pre-processing data in the official split, so we're going to click that one as well. The data set for evaluation used, you can just find out what data set was used in here. Control F for this one specifically. It was the MNIST and the Urban 8K sound, so we're going to have a different one. It isn't within this up here. We can just Control F and try and find MNIST. And this is the only place it's kind of, where I have put it is the only place that is in there. But because it's not up in the options that are provided, we can provide that right here. A motivation also is given within the paper itself for the selection of these two. And then also all of the data sets that we used, which again was just the MNIST and the Urban Sound 8K, were publicly available. I had to use them to be able to reproduce the results. So yes, they are publicly available. The baselines that were tested against, they report in this right here. Up a bit on the different baselines. Where is it? Right here. So they state that they use a LSTM, a C3D, and then as well as Neuroplex. So those were the 1, 2, 3 different baselines that they use, and then they also do ablations with the different windows and noises that were used throughout the whole thing. And they do quite extensively report down here within their results section on all of that, looking at all the windows that they were using and all the different ablations that they were using. So this is something that you'll have to draw out from the paper itself. And then for the reproducibility, there was not any human evaluation in this, so we're just going to leave that one blank. And then for the reproduction output, we were able to fully reproduce everything from this one right here. And we were able to do that within 1% of the reported results, which is well within the error bars that were reported in the paper itself. So after we've done all that, we can now come through to the final section, the decision section, section 9. We are going to include this. We don't have to provide this right here because that's only if we exclude. And then if we do choose to include it, just one sentence describing why this paper should be included within the review. For this paper that we've just gone through, which is Deep Prob SEP, I have said that we should include it within the review because it provides evidence that differential probabilistic logic can drastically reduce data needs for neurosymbolic complex event-driven processing, and this survey is on neurosymbolic processing. We were able to reproduce the results. It is a neurosymbolic system, so this is something that we want to keep in the survey and we want to report on. And with that all done, we can then submit. So that was the full run through on the data extraction phase for the Neurosymbolic AI 2025 systematic literature review. If you have any questions, please feel free to reach out. You can find me very easily if you just search my name. I'll put my contact details down below as well. If you have any questions or if you would like to join the study, please send me a message or email me and we can talk further. Thanks very much for listening, and I hope to see you in the very near future.